Hi guys, so I'm quickly going over the 2024 set for chapter number 1, which is electronic configuration and ionization energy. Let's just quickly go over these MCQs. Where can these MCQs be found? You'll get these MCQs sooner or later. These are still in the process of being compiled, and so I'm just quickly gonna solve a couple of MCQs just to remove the fear of MCQs, right? So just solving the 2024 set for chapter number 1, however many MCQs there will be, and then we're gonna commence with our daily class. Okay? So this is gonna be our approach. Now, because we are almost done with the 4th chapter, periodicity, group 2, group 17, nitrogen and sulfur, we're done with ionization energy, we're done with chemical bonding, we're done with redox. Now we are slowly and gradually in the process of to be able to do MCQs, right? So now we are slowly and gradually in the shape of doing MCQs. So before every single class, we're going to do a couple of MCQs, 5-10 MCQs before every single class for the prior chapters. Okay, so this pertains to chapter number 1. It'll be uploaded onto your portal under the tab topical MCQs, and it'll be added to the relevant chapter. Okay, so Bismillah. 2024 November 1-2 question number 1. Which species contains a different number of electrons from the other 3? So you just have to figure out which of these have different number of electrons. You just go to the periodic table, take out their protons, and the protons should be equal to the number of electrons for all the atoms, right? So if chlorine is here, chlorine has proton number 17. It has 17 electrons as well. Oxygen has what's the proton number of oxygen? Can somebody check? That's probably 8. So oxygen has 8 protons and they should have 8 electrons. And how many O's do you have? 4 O's. So you add all of them. What do you get, sir? What do you get? 17 plus 8 times 4. 8 times 4 is what? 32. 32 plus 17. Yeah? Somebody help me out, please. So 8 times 4 is like 32. 32 plus 17 is 49. That's 49 electrons, right? But you also have a 1 minus charge, which means that there's a gain of an electron. It's the ion. So in total now you have 50 electrons for ClO4 minus, right? Now, H2SO4, hydrogen has 1 proton, therefore should have 1 electron as well. You have 2 hydrogens, times it by 2, sir. Sulfur has, what's the proton number of sulfur? If I'm not wrong, that's 16. You could check the periodic table out for it. Oxygen is obviously 8, times it by 4 because you have 4 O's. Can everybody add all of these together? No negative charges. There are no negative charges. So these will be the number of electrons, because for atoms, protons and electrons are equal. What do you get, sir? What do we get? The same. 18 plus 32, that's 50. So that's the same, right? He's saying you have to select whichever one is different. So A and B are same. C, sulfur, again 16, and you have oxygen, which is obviously 8, times it by 4 because you have 4 O's, and you need to add, what do you get, sir? We get 48 if I'm not wrong, and it has a 2 minus charge, which means it has gained 2 electrons. So this is also 50. So A, B, C are all similar. You just need to check out which one is different and which one is same but different. Te 2 minus. Why? If you check Te out, Te has 52 proton number, therefore it should have 52 electrons, but it's a 2 minus ion, therefore you add 2 more electrons to it. 2 minus means it has gained 2 electrons. It has 2 more electrons than protons. So if it has 52 electrons and 52 protons for Te, then it should, if it's Te2 minus, it should have 2 more electrons. So in total it has 54 electrons, and therefore D is the one which has different number of electrons. Now this is one way to do it, but in the exam we don't have this much time, right? So if you want, you could do it like this, but in the exam, let me teach you another quick method. You need to know these shortcuts for MCQs. I could have done this MCQ in the first 10 seconds. How in the first 10 seconds? And remember, these MCQ questions are so important. The way I'm solving it is so important. It's because it's going to save you a hell out of time. So if you check this out, you know chlorine is 17 minus, there's also a minus charge. So in total, these are going to give you 18 electrons. And if you check this out, there's O4 here, O4 here, O4 here, right? So they all have 4 oxygens in A, 4 oxygens in B, 4 oxygens in C. So the electrons of 4 oxygen, 4 oxygen, 4 oxygen in A, B, C must be equal. Sulfur is 16, has 2 electrons, so it has a 2 minus charge, so 2 more electrons, that's going to be 18 right here. Similarly, 16 plus there are 2 hydrogens, so 2 more electrons, that's 18 here, plus this is already 17 minus 1, so that's 18 electrons here. So you'll realize that they're all equal. You did not need to compute oxygen for it, and these things will save your time, right? So that's MCQ 1, D is the correct option. MCQ 2. Which factor causes helium to have a higher first ionization energy than hydrogen, right? So if you check helium out, helium is 1s2, right? And hydrogen is just 1s1, right? And what could be the reason for it? Well, we all know it is higher nuclear charge. They're in the same period, right? So effective nuclear charge or higher nuclear charge of helium is the reason why it has a higher first ionization energy. But let's look at all the options. The key to doing MCQs in A levels is to be smart about it and to read all the options. Don't skip on any options. Have a broader and holistic view towards it. Okay. So he's saying the reason why helium has a higher first ionization energy is because in the 1s orbital in helium, electrons are paired. Sir, hold up. Are you joking? I know helium has paired electron, but paired electron results in lower first ionization energy because of spin pair repulsion. So that's not the reason why helium has a higher first ionization energy. It should have, if you just look at this factor alone, then helium should have a lower ionization energy, but that's not the case. The lowest energy level in helium is filled. What the hell? Why? Because the lowest energy level in hydrogen is also filled, in helium is also filled. They are both 1s and 1s. So that's not the reason why it has the higher ionization energy. The nuclear charge in helium is higher than in hydrogen. Yes, sir. Because if you check helium and hydrogen out, the fundamental difference between why helium has a higher first ionization energy is because across the period what's happening is that the shells are the same. So the shielding effect is almost constant, but helium has one more proton, and that one more proton results in a higher nuclear charge, and therefore it has a higher ionization energy. So the nuclear charge on helium is higher than in hydrogen. Absolutely correct. Helium has a +2 or a 2+ nuclear charge, and hydrogen only has a +1 nuclear charge. And +2 would have a stronger pull on the valence electrons. There is less shielding. No. The shielding across the period is almost constant. So no less mess. What are you saying, examiner? D is wrong. See, that's how you do MCQs. Pretty simple, pretty logical, easy peasy. Next, Z is a compound of 2 elements X and Y. Element X shows a very large increase. So Z is made up of one element called X and the other element called Y. Element X shows a very large increase between the 5th and the 6th ionization energy, which means that the 6th electron is removed from a shell closer to the nucleus. That in turn means what? That X has 5 electrons in its outermost shell. So therefore it's going to be in group 5 or group 15. That's what I can safely deduce, right? And element Y shows a very large increase between the 6th and the 7th ionization energy, which means that the 7th electron must be removed from a shell closer to the nucleus. That's why it has a higher, there's a very large increase, the big jump between the 6th and 7th ionization energy, which in fact means it has 6 electrons in its outermost shell, therefore belongs to group 6, right? So one is in group 5, the other one is in group 6. Now we have to figure out which element it is. He's also given you extra details. He's saying it has the second largest first ionization energy in the group. Let me show you the periodic table. I can't answer these questions without the periodic table. I have not learned the periodic table, but one is in group 5 or group 15 right here, and the other one is here. Now he's saying that the one which is in group 5 has the second largest first ionization energy. You know that ionization energy decreases down the group. So if it's at the top, that should be the highest ionization energy. But if it's at the second highest ionization energy, that must be phosphorus. Because we know the reasons why ionization energy decreases down the group. You know that the increase in nuclear charge is outweighed by the increase in shielding and the increase in atomic radii. So it's basically phosphorus we're talking about, and in Y he's saying it has the largest first ionization energy in its group. So we know it's in group 16, and the largest first ionization energy is oxygen, and we know phosphorus and oxygen exist in the form of P4O10, and that's the beauty. P4O10, C is the correct option. That's why I always say concepts are so important. MCQs are a piece of cake. Raima, revise chapter number 1, ionization energy. Next, which statement about I is correct. Okay. A negative ion of I, it contains 53 neutrons and 52 electrons. First of all, let's figure out the number of electrons if it's a negative ion. We know that if you have I in the periodic table, it's in group 7 or group 17, it's going to gain 1 electron to become a stable electronic configuration, and therefore it should have a charge of 1 minus. Now if it has 53 protons and it has 53 electrons for the atom, how many electrons would there be for the 1 minus ion? It should be 1 more. So it should have 54 electrons. Therefore, A and C are automatically wrong. You know, A has 52 electrons, C is also showing 52 electrons. They should have 54 electrons. Now, how many neutrons does it have? How do you calculate the number of neutrons? This is the mass number. 131 is the mass number, which is equal to the total number of protons plus neutrons in the nucleus of the atom. 131 should be equal to the number of protons, and let's calculate the neutrons. How many neutrons do you have? Protons are these 53, right? So that doesn't change. 131 minus 53. What do you get? 131 minus 53. What do you get? 78, if I'm not wrong. So it must have 78 neutrons and 54 electrons. And how many protons? 53. So the negative ion I contains 78 neutrons and 54 electrons. D is correct. Why is B wrong? Because it's saying 53 neutrons. No, 53 are the number of protons. B is wrong. Done. The first 8 successive ionization energies of 2 elements of period 3 of the periodic table are shown. So period 3K, out of period 3, 2 elements successive ionization energy is shown. So it's for the same 2 elements you are plucking an electron over and over and over again. And if you look at the ionization energy, realize, see, he's removing the electrons. There's a large jump between the 7th and the 8th ionization energy, which means what? That the 8th electron is removed from a shell closer to the nucleus. If it's removed from the shell closer to the nucleus, that means that the outer shell contained how many electrons? The outer shell contained 7 electrons. And if you still can't get your head around this, you need to revise chapter number 1. I've taught this in so much detail that you can't even imagine, you know. And if you want me to just quickly give you a quick understanding of this, see, if you have 1, 2, 3, 4, 5, 6, 7, and here you have electrons, right? So what has happened is you've removed the first electron, the second electron, the third electron. They're removed from the same shell. The 4th electron, the 5th electron, the 6th electron, and the 7th electron. You removed all 7 electrons, and then when you start removing the 8th electron, you realize that the 8th electron is removed from a shell closer to the nucleus. That is the reason why there's a big fat jump in ionization energies, right? So the outermost shell contains 7 electrons, right? That's how you realize. And similarly here, there's a big jump between the second and the third ionization energy, which means that the third electron is removed from a shell closer to the nucleus. So if it's being removed from a shell closer to the nucleus, the outermost electrons should be 2. So they're both in period 3, but if the outermost electrons are 2, this should be in group 2 period 3, and this fella should be in group 17 or group 7 period 3, right? So one is in group 2 and the other one is in group 7. Check this out. Oops, my bad. Check this out, fellas. Check this out. So this is my period 3. See, this is period 1, the first horizontal row, period 2, the second horizontal row, and period 3. So period 3, group 2, and period 3, group 17. So magnesium and chlorine. It should be MgCl2, magnesium chloride, that the guy is talking about. And pretty much that's the answer. So it's what? MgCl2. You're talking about. This is chlorine and this is Mg. Done. So MgCl2A. Easy peasy, lemon squeezy. Yes, Raima, if there are 5 electrons in its outermost shell, that means it's in group 5. That's pretty O-level stuff, Raima, kiddo. Khair, what is the total number of protons, neutrons, and electrons present in an ammonium ion? Now, this MCQ is poorly constructed because he's saying, what are the total number of protons, neutrons, electrons present in an ammonium ion with a relative formula mass of 21, which means that this is effectively the mass number. The mass number equals 21. That's what he's saying, right? And ammonium ion is what? NH4 plus. That's the ammonium ion. Now, if the mass number is 21, you know that mass number equals to the total number of protons plus neutrons in the nucleus of the atom. How many protons does nitrogen have? Well, nitrogen has 7 protons. You can check the periodic table for it. We're not talking about the mass number, the number of protons, right? So we're not talking about the relative atomic mass for nitrogen, which is 14. No. We're talking about the number of protons, because once we figure out the number of protons right here for ammonium ion, we'll just plug it here and figure out the number of neutrons. So nitrogen is 7, hydrogen has 1 proton, times it by 4 because you have 4 hydrogens, add them together, what do you get? 11 piece. So the ammonium ion has 11 protons. And if it has 11 protons, how many neutrons should it have? 21 equals 11 plus n equals 21 minus 11. What do you get, sir? 10. 21 minus 11, 10 neutrons. So 11 protons and 10 neutrons, 11 protons and 10 neutrons. Therefore, B and C are automatically wrong. And you know, if I were you, I'd be even more smart about this. This is my job to explain the entire MCQ to you guys, but I'd automatically circle A. Why would I circle A? Now, the smart work for it. First, I'll teach you why I've circled A, and then I'll complete this, right? The reason why I circled A was because you're saying it's the ammonium ion. It's the ammonium ion. It's the ammonium ion. And you know that for ions, the number of protons and electrons aren't equal, are they? The number of protons and electrons are equal. Here he's saying it has 11 protons, 11 electrons. D is automatically wrong. That's what I saw with my naked eyes. That's what I saw with my naked eyes. Even I could have directly cut out C and D because it's not an ion. Because for an ion, the number of protons and electrons should be different. But they're the same. 10, 10, 11, 11. So C, D automatically cut. And between A and B, I know the number of protons are 11. Done. A is the correct option, right? But if I were to prove it to you, now you figured out the number of protons, which are 11, the number of neutrons, which are 10. And because it has a 1 plus charge, how many electrons should be there? Well, for NH4 only, it should be 11 protons, 11 electrons, but it's a 1 plus charge. Therefore, it should have 10 electrons. And that's why 11 protons, 10 neutrons, 10 electrons is the correct option. Right? That's pretty much it, right? So you need to, I'm also teaching you guys the smart way, and I'm also teaching you guys the logical way. So smart way, logical way, smart way, logical way. This question is, and this MCQ is poorly constructed, extremely poorly constructed. Why is it poorly constructed? At this level, you don't need to know it. You know, if it was the Cambridge examiner I was talking to, I would probably tell him why it's poorly constructed. This question is about the first ionization energies of magnesium and neon. Which is correct? Which of these two would have the higher ionization energy? The first higher ionization energy. Look at the periodic table for it. You know, ionization energy increases across the period, decreases down the group. Neon is right here, but magnesium has one more shell. Magnesium has one more shell than neon. Neon has a very high ionization energy compared to magnesium because magnesium has one more shell, and because of the higher distance, the net nuclear attraction is lower, and therefore ionization energy is much lower for magnesium compared to neon, right? So neon has a higher first ionization energy. A and B are wrong. And where is the electron removed from? We know that this is the S block. See, we've already labeled our periodic table. This is the S block. So magnesium electron is removed from the S, and this neon is in the P block. So neon's outermost electron is removed from the P orbital. Because realize the reason why an element is in the P block is because the highest energy electron or the outermost electron is going to be in the P orbital. That's why it's in the P block. Why is magnesium in the S block? Because the highest energy electron or the outermost electron is in the S orbital. And you can even check it out. Magnesium is what? Neon. This is the electronic configuration for magnesium, the shorthand one. Neon 3s2. So where would the electron get out from? It would go from the S orbital. Right? So magnesium loses it from the S. See, where does magnesium lose it from? From the S. And neon loses it from the P. So D is correct, C is wrong. Poof. Next. Which species contains the same number of neutrons and the same number of electrons as this? How many neutrons does this have? 14 minus 6. That gives me what? 8. You know, and why am I doing it? You guys know this from O levels and IGCSE. See, come on, that 14 is the mass number, and the mass number equals, or the nucleon number equals the total number of protons plus neutrons, and protons are 6. So just substitute P instead of 6n, and then that's just a simple equation. 14 minus 6, that gives me 8. Please. Okay, and then the same number of electrons as this. How many electrons does it have? For sodium, only for sodium, it must have 11 protons and 11 electrons. But if it's a 1 plus ion, now it should have 11 minus 1. It should have 10 electrons, right? Because if it was just sodium, 11, it should have 11 protons and 11 electrons. Because for an atom, the number of P's and E's are equal. But if it's a 1 plus ion, it means it has one fewer electron compared to proton. So now it has 10 electrons. So check something out which has 8 neutrons. We need to figure out the particular species which has 8 neutrons and 10 electrons. Automatically A is wrong because A has 9 protons and it's an atom, so it must also have 9 electrons. It doesn't fulfill the electrons. I'm going to move on to the next one. This has how many electrons? 7 plus 3, because it's a 3 minus ion. So if it was just n, 7 p's and 7 e's, 7 p's and 7 e's, but it's 3 minus, so 3 more electrons. So 10 electrons, good stuff. Electrons are fulfilled. 16 minus 7. How many n's do I get? 16 minus 7, that's what? That's 9 n's, I think. Right? So that's incorrect. I need 10, I need 8 n's, right? Similarly here, it has 10 electrons. And how many protons does it? We don't need to look at the protons. How many neutrons does it have? 20 minus 10. That's 10 n's. How many do I need? I need 8. So C is also wrong. Here, 8 are the number of protons and electrons, but if it's 2 minus ion, then it must have 10 electrons. So electrons are equal. And 16 minus 8, what does that give me? 8 neutrons. So 8 N's and 10 E's fulfills it. D is the correct option. That's it. You guys think A-level MCQs are difficult? If you thought that before this class, you should have just jumped off the roof, because I know I'm joking. A-level MCQs are the easiest, and I'm proving it to you. I've done 9 MCQs, and this is the recent 2024 papers. So I'm going to do till 9, and then we're going to look into our class. Please understand that, just like I said before, I'm going to start doing MCQs, and these are slowly being compiled. So for now, just look at this beautiful worksheet that I have, right? They're still in the process of being compiled. Now, which process has the greatest enthalpy change per mole? We've not studied what enthalpy change is, but remembering from O levels and IGCSE, you could just think about it. Which of these would have the highest energy requirement? You could simplify it for this. Largest enthalpy change, largest energy change, right? The largest energy change would be for the one which requires the highest amount of energy to remove the electron, right? We all need to remove electrons. Aluminum 3 plus, removal of electron. P5 plus, removal of electron. S6 plus, removal of Si4 plus, removal of electron. Why are you saying C, Raima? Why are you saying C? Come on. I also need the logical reasoning for it. 7 electrons, absolutely incorrect. Absolutely incorrect. See, that's what I say. Don't tokkafai stuff. Don't make your own reasons for it. You guys can see something here. What is this? Have you seen such sort of, ions before? Aluminum, phosphorus, silicon, sulfur. That's why I said chapter 4 was very important, because now after chapter 4 you are able to do the first 4 chapter MCQs. What is this? Isn't this period 3 for you? Isn't this period 3? It is period 3. Ain't that true? Aluminum, sulfur, phosphorus. That's why periodic table should be by your side all the time. So this is period 3. If I just arrange this is basically aluminum comes first, then it's Si4 plus, then it is like P5 plus, and then it is like S6 plus, right? And I've arranged it, right? And we're removing electron from each and every one of them. Now the question is, which should be the answer? Which one should have the highest energy? Which one should require the highest energy to remove the electron? Shabash. See, it's so logical now. It's so logical. I need the answer to this. Don't rote learn it. Don't rote learn stuff, please. This is 13 protons, 14 protons, 15 protons, 16 protons. Whoever gives me the correct reasoning for it will win rupees 100. Shabash. It's pretty simple. Do you want me to give you a hint? Write the number of electrons. Absolutely wrong. Absolutely wrong, Raima. Absolutely wrong. It does not have to do with, it's across the period, so but that's why. No. Give me the pinpoint reason for it. What if this were to come in theory? Yeah, what if this were to come in theory? You would say, it's 6 electrons required, so blah, blah, blah. No, you won't say that, right? Would you? Okay, I'll give you a hint. Write the number of electrons for all of them under it. I'll give you the hint. How many electrons does this have? 10 E's, 10 E's, 10 E's, and 10 E's. They all have 10 E's. Do you want me to give you the last hint? Come on, guys. I've taught this. Kya ho gaya? I've taught this. They have the same number of electrons. Shabash. Then what do you need to look at? They're across the period. They are all. What is this? What is this called? If they have the same number of electrons, what are they called? They're all called isoelectronic. They have the same number of electrons. Absolutely incorrect. Raima, nahi yaar, nahi. The idea is what? They're pulled by the more number of electrons. What do you mean more number? They all have the same number of electrons, guys. It's just across the period, the number of protons are increasing. For isoelectronic, I also taught you guys the hint for it. I can't help you guys if you've forgotten the basic concepts. For isoelectronic, what does ID have to do here, Manur? For isoelectronic, I taught you guys something very simple, that the higher the nuclear charge, the higher the ionization energy for isoelectronic. Because why? Because the ratio of protons to electrons increases, P to E's increases. You have more P's. See, sulfur has 16 protons, but they all have the same number of electrons. So more protons are pulling the same number of electrons, not more number of electrons. So what is the correct option? Sir, which one has the highest ionization energy? That one would have the largest enthalpy change. So the high ionization energy is for S6 plus. So the C is the correct option. Because C, it has the highest nuclear charge, and they're all having 10 electrons. They're all isoelectronic. 10 electrons. So the higher the nuclear charge, the higher the ionization energy, and therefore the larger the enthalpy change per mole. So some of you guys gave me the correct answer, which is C, but you did not know for the love of you to why C is the correct option. Yeah, no, I've taught this effectively. I think I taught this where in chapter number 2, I guess. In chapter number 2, we learned the concept of isoelectronic. So it's so simple, so basic, so simple कि मैं आपको क्या बताऊं. But again, I always say A-level MCQs aren't difficult. Your concepts should be on point. So some got disappointed with this MCQ. All the others were fine, but this MCQ nobody got it right. Chalo, I'll upload this and you guys can later on go over it. And for now, we'll just continue with the class. Okay, bye, ciao, bye.